Hello and welcome to Podcast.init, the podcast about Python and the people who make it great. I would like to thank everyone who has donated to the show. Your contributions help us make the show sustainable. For details on how to support the show, you can visit our site at pythonpodcast.com. Linode is sponsoring us this week. Check them out at linode.com/podcastinit and get a $20 credit to try out their fast and reliable Linux virtual servers for your next project. We are also sponsored by Rollbar this week. Rollbar is a service for tracking and aggregating your application errors so that you can find and fix the bugs in your application before your users notice they exist. Use the link rollbar.com/podcastinit to get 90 days and 300,000 errors tracked for free on their Bootstrap plan. You can also visit our site to subscribe to our show, sign up for our newsletter, read the show notes, and get in touch. And to help other people find the show, you can leave a review on iTunes or Google Play Music and tell your friends and coworkers. You can also join our community. Visit discourse.pythonpodcast.com for your opportunity to find out about upcoming guests, suggest questions, and propose show ideas. Your hosts, as usual, are Tobias Macy and Chris Patty, and today we're interviewing Lazar and Zheng about the Onion IoT platform. So could you guys please introduce yourselves? How about you go first, Zheng?
Okay, so I am one of the early founders of the company. So the company was founded 2 years ago. The initial idea of Onion was we want to build a platform so that people can easily create connected devices. So we started with this software platform that allows you to connect hardware to the cloud and to remotely access it from anywhere in the world. And then later on down the road, we discovered that there aren't that many hardwares that's specifically designed for this kind of low power communication purpose. So that's how we came up with the Onion Omega, which is a tiny Linux computer that's specifically designed for IoT. And it has all our software built in. So once it boots up, it connects to our cloud and everything will be taken care of. From the developer's point of view, they can just go in and program in high-level languages such as Python, and this will make their life much easier.
And Lazar, can you introduce yourself?
Yeah, for sure. So I joined Onion this summer, actually. I came aboard as a late-to-the-game co-founder, and I worked for a large tech company previously. And when I first spoke to Boken and Zheng about Onion and the Omega, I was absolutely floored. Having such a successful Kickstarter and such a captivating product, at first I was like, okay, how many of these can I get right now? And then when I realized, oh my God, I could actually work on this and make it better, be a part of the development and be a part of this team, I was ecstatic. So I came aboard and I've been working on largely the applications on the device, dealing with the firmware, more low-level stuff to enable the higher-level programming that the Omega provides for developers.
So how are you folks introduced to Python?
So I actually learned about Python during my university years. I was searching for easy-to-use programming languages to do side projects. By the time, there aren't that many scripting language that's as complete as Python. If I remember correctly, Node.js was not even available back then. And so the first time I got introduced to Python was working on a project where I got different wireless sensors that samples temperature readings and send it to a computer. So the reason I chose it is because the string parsing capability in Python was much, much stronger than using C. And that's how I got into it, and I was hooked since then. The syntax was clean and everything was really easy to use.
So my story is a little different. At work, during one of my internships, I discovered Perl. And I started working with Perl and wrote a whole suite of scripts for that that placement. And I was like, oh, okay, this is great, so much easier than C. And then at a hackathon, we were making a web-enabled IR remote. And one of my teammates was just like, I was going to write it in Perl. And he's like, why don't you just try out Python? And I was like, okay, sure, why not? And I picked it up really quickly, and then I started working again. They'd had a whole suite of scripts in Perl, so I kind of went back to Perl. And then when I joined Onion, there was, I can't even remember, but Zheng and I were talking about something, and I was like, oh, okay, I'll just write a Perl script. And he's like, Perl, that grandpa language? Come on, do something more modern. Try Python. And like ever since then, I've been hooked, and I'm writing Python scripts on a weekly basis now.
The fine tradition of shaming in computer science.
Well, to be honest, and to be perfectly fair, Perl is a grandpa language. So I do agree. Now that I'm more versed in Python, I was missing out for a few years.
So, Zheng, you alluded a little bit to this question, but what is the Onion platform and how does it leverage Python?
Yeah, so as I mentioned before, like initially it was just a cloud software that allows devices to connect and communicate with each other. But since we came up with the Omega, we started to build a device level framework as well. So the way that we use Python is to build a generic application framework. So people can just take the template and implement a few functions, and our cloud will take care of the rest and make it available online and make it easily accessible through web APIs. So Python is not the only language high-level language that we support here. We also support Node and PHP, but the general idea would be a set of code that people can import and just write a few lines of additional code to make it work with our platform.
And what kind of apps would you typically write or run on the Onion platform or on the Omega itself?
So there are two sets of apps. There's one set that runs on the device, and that's where Python was involved. Is to extend the functionality of services that the device is offering. So once you add the services onto the device, the cloud platform will pick it up and make it available as sets of REST APIs. At that point, you can now write mobile or web apps that can directly interact with your device.
So can you compare and contrast the Python support you provide for Onion as compared with Raspberry Pi?
So one of our current drawbacks in terms of our Python support is that we do not fully support pip. So the Omega it has a tiny MIPS processor on it that's 400 megahertz, so it's not really a conducive environment for a C compiler. So any modules that require compilation during the installation process cannot be installed on the Omega right now. However, we are working on a cloud compile environment that will be accessible to our users. And as a part of that, we'll be including support for pip, so installing any packages with pip.
So you say that it's not possible to compile it at install time, but would it be possible to, for instance, generate a wheel archive and then ship that to the Omega to execute?
Yes, that's going to be the plan down the road. So we are going to make a repository of all Python packages that's pre-compiled for the Omega platform. So the users can just download them and install it instead of having to compile it on the fly.
And one thing that I'm curious about with thinking about installing packages is how much storage space is there available on the Omega, and is that expandable?
So the Omega comes with 16 megabytes of flash storage, which is a little low, but you can expand the storage with USB. All of our docks have USB host ports, so you can either expand the storage or you can completely move the file system of the Omega to the USB drive.
And I noticed that you're using the OpenWRT distribution of Linux in order to provide support for those multiple languages. I'm wondering what the driving intent was behind choosing that and why multiple language support is so important for an IoT product.
Yeah, so OpenWRT was initially designed for wireless routers. And right out of the box, it supports basically all modern telecommunication protocols. So that's a really good starting point for IoT applications because even till now, there aren't a basic standard for IoT communication. So we want to support as many protocols as we can without needing to go in and start to port over them one by one. So that's why we chose the OpenWRT platform. And for languages, it's basically the same idea. We don't want to lock the user into one language. We want people to develop in a language that they feel comfortable with. So by having a Linux operating system, this helps a lot.
Yeah, just to add on to what Zheng said, yeah, so OpenWRT, additionally, is also very small. So it doesn't have any excess fat, and any fat that it might have, we're able to trim down. So it was very, very conducive to our Omega environment. And yeah, like with the multiple languages, we believe that only if you love what you're doing will you actually create the greatest products or the greatest content. So if you have a great idea in mind, but you're tied into using a language that you don't get or love even, I don't think the product will be as good. So the intent behind multiple language support was if you have a great idea, you can code it in whatever language you want. That shouldn't be a barrier. Languages are, there's so many of them these days, and everybody has their own favorites. So we wanted to allow people to just work with what they're most comfortable with. So just really open the door to all sorts of projects and all sorts of developers. I mean, right now, software developers are realizing, hey, like making hardware is, not only is it fun, but now it's becoming easy. And platforms like the Omega allow somebody with minimal hardware experience to come in and use languages that they know and love, Node.js, Python, and create their own hardware devices that are connected and accessible from anywhere in the world.
And do you have any intent to expand the choice of languages that you're going to support on the Omega? And also, as a corollary to that, what does language support look like on the Omega platform? Does it require a certain set of APIs that are exposed as bindings to that language? Or could you, for instance, just put whatever language you wanted onto it that is supported by OpenWRT and start using the Omega, even if it's not one of the languages that you list as being supported?
Right. So for Python and Node.js, you just have to use the package manager and install the packages to provide the language support. Right now we do offer some Onion customized modules for Python. We're working on those for Node.js as well.
So basically, I don't know how much you know about OpenWRT, but they have a really good hardware abstraction. They have something called U-bus. It's basically a message bus sitting in the operating system that abstracts a lot of functionalities of the OS into a socket. So at this point, it doesn't matter what kind of language you use. You can access the low-level functions all through the U-bus service. So the plan going forward is not to come up with specific libraries for each language, but to make hardware level access available over the U-bus service and then we'll provide a simple library to each language that access the U-bus. So by doing that, we don't have to go over all the functionalities again and again when new language is supported on the platform.
That's super smart. I think that it's really nice to see Linux distros coming up with abstractions like that make sense. I wish more distros would come up with abstractions like that. I think it would make everyone's life easier and also increase Linux's adoption in more contexts.
Yeah, there's a lot of really good things that WRT has done. It's actually a really powerful little system.
Yeah, I use it for my wireless router and have done so for a few years now. And I think part of the driver for their innovation is because they're working on such constrained hardware that they have to come up with different ways of tackling some of those problems versus some of the other distributions that are targeted more for servers or desktops that have much more capacity to work with, so they don't have to worry so much about how to handle different hardware interactions. And also because of the fact that OpenWRT is targeting such a wide variety of such limited and embedded hardware, that too contributes to the need to be able to handle that kind of environment in a sane manner.
Yeah, agreed. I wouldn't say necessity is the mother of invention in this case. It would be more constrained hardware is the mother of invention.
I just want to add a bit on the same train of thought. So the UBus service, it doesn't just provide us with with an abstraction layer for low-level hardware access. It also helps us to interface with the device in many different ways. So I just described one use case where we just provide a thin layer for people to access the UBus from different languages. But there's also a way for you to expose the UBus over the network with a HTTP server. So that instantly transfers all your device level features into a HTTP service. And on top of that, we can build another client that exposes the same features over the cloud. So the use case, there's a plenty of use case you can use just with this simple service that they provide.
Yeah, I can definitely see how that would be very useful, in one aspect for command and control purposes, but also for monitoring of the hardware status of your different devices. That would definitely be very powerful. And one thing that I'm curious about is, given that this is targeted for IoT and small embedded hardware, do you have any sort of GPS support or any modules that you can use to expand the Omega to add that kind of support so that you can then query each device to find what its location might be?
Yes. Actually, we do have GPS expansion. It's just it's part of our Omega family. It's a USB device built specifically for the Omega. So you basically plug this USB device into the Omega dock, and it will just show up automatically as a UBus service. It's called like GPS UBus service. And then by querying that endpoint, you can get location, bearing, speed, and I think there's a few other attributes you can get with GPS. And yes, so this is already available.
That would have come in very handy when I was working a few jobs ago where we had distributed sensors and needed to track their coordinates, basically using a spreadsheet or database table and having to go out to each one and find, record its GPS coordinates based on what we pulled off of our phone or whatever we might have handy with that capability. So we talked about it a little bit as far as some of the different Python libraries that you provide for abstracting away some of the hardware level tasks, but what were some of the design considerations that you guys had to tackle in order to provide a more unified experience for the different languages, and I guess just some of the more interesting design problems that you've come across both at the hardware and software level?
Well, the libraries and packages that we currently support, they're actually all based in C. The actual kind of user space drivers I wrote them in C, and then I had to figure out how I can make that into a Python module. I thought at first I was like, oh man, I'm gonna have to rewrite all this code into Python, but then Zheng's like, no, like Python and C are very, very related, and you can use your existing C code and create a Python module. So I went about that, and really the main design consideration was how to present this to the user in a way that makes sense. So a better example would be the servo expansion. The servo expansion has 16 channels, and so would it make more sense to have an object where you specify the channel that this object will be programming, and then have the user create as many objects as they need, or just provide functions where you just pass in the channel number and the pulse width modulation duty cycle? So it was little things like that were really the main design considerations, how the users will experience it and how the users will what would be most useful for the users.
And while we're on the topic, can you just give some more detail about the actual hardware specs that are on the board? And I guess some of the things that make it stand out versus some of the other IoT boards that are available, such as the Tesla or Arduino or some of the other different products in that space?
Right. So the ones that were really like wow to me when I first heard about the project were the onboard Wi-Fi and storage. So when you get your Omega, you plug it into the dock and you use a micro USB to provide power, and you're ready to go. You don't need anything else. Previously, I'd been doing some projects using a Raspberry Pi, so I got the Raspberry Pi and I was like, okay, I need an SD card. I got an SD card. Well, now if I want wireless, I have to buy a wireless dongle. So it was just a whole bunch of waiting and extra money being spent. So I really like how the Omega is just literally plug and play, and you can just plug it in and go right away. Another thing that I really dig about the Omega is the modularity of all the expansions. So if you have a project that needs a screen and a servo, that's great. If you don't need one or more of those things, you can just pop it right off the expansion dock. When you're comparing it to the Arduino, it is more powerful because it does have connectivity, but it also has Linux, so you can schedule more things. It's not just a one-trick pony. And we actually do offer an Arduino dock where it's essentially equivalent hardware to the Arduino Uno, and there's a socket for the Omega, so the Omega can actually program the ATmega microcontroller and then communicate with it through I2C if your project requires a need for a microcontroller.
Yeah, I've definitely heard of people using the Raspberry Pi for that kind of purpose, but having something that's a little smaller form factor and more self-contained, I can definitely see as being beneficial, particularly from a power standpoint. Speaking of which, what are the power requirements? And I guess if you were to try and deploy an Omega in an environment where you didn't have access to a power outlet, what sort of batteries would you be attaching to it?
So I think we used like a 15,000 milliamp hour battery, and we ran an Omega for about a week.
And that's like when the Omega is always on and transmitting. So to extend the battery power, you can always put the device into hibernation mode, which will like basically draw near to zero power. And based on our schedule, it will just wake up, does its transmission, and then go back to sleep again. We haven't done a test about that, but I think it's gonna extend the battery life for a long, long time.
So what are some of the most interesting projects you guys have seen people do with Python on the Onion, Omega, and the other platforms that you expose?
I recently saw one where it was being used as essentially a remote control for a 3D printer. So it would plug into the serial port of a 3D printer, and the user would upload the G-code file with the instructions for the 3D printer. And a Python script would actually use the USB as a serial port and would send the instructions one by one to the 3D printer, waiting for OK response and then moving forward to the next instruction. And they had actually used a webcam as well to babysit the print from another room, because like we have a few 3D printers at the office and they're very noisy, very distracting when you're trying to work and build things. So we keep them closed in a conference room, and we just watch them with the USB cameras. And this project, combined control and monitoring of 3D printers. So I thought that was very creative.
Yeah, that does sound interesting. Do you typically see people using a single Omega at a time for a given project, or do you think it's more common for people to deploy clusters of them for a more networked or distributed capability?
I think at this point, people are just exploring the Omega right now. I don't know how much of a connected application as people build. But once we have launched our app store on the cloud, I think there's going to be more people coming up with interesting applications that utilizes more than one.
And I think one of the things that's powerful about having a networked platform like the Omega is that you can update the code on it remotely rather than having to go and collect the devices and reflash them with the new instruction sets like you would with something like an Arduino.
Yeah, about that, I want to expand on that topic. So in most of the IoT boards, they are just a microcontroller. So the only way to update the functionalities of that microcontroller is basically to reflash it. And people came up with multiple over-the-air firmware upgrade protocols for that. But for Omega, since it runs Linux, updating the functionality of the device is basically just updating a software package in the OS. And this will not disrupt your operation. This will, and it will update like really quickly and really stably.
One of the things with a lot of other IoT development boards is that they're microcontroller based, and if you want to change the functionality of the device, you have to reflash the microcontroller, bring it down and reflash it. Other companies have come up with methods to do this over the air. The thing with the Omega is that updating any software functionality is just done by updating a software package. So this can be done remotely, and it can be done quickly and in a very stable manner. So you log into the cloud, you say, okay, I want to push this and this software to this and this device. You click and it's done.
Bringing up the login raises another question as to what sort of access control or security mechanisms you have in place for restricting access to the Omegas to make sure that some rogue agent doesn't just find the device, figure out that it's there, and start trying to use it for their own purposes.
Yeah, so we have a unified account system in Onion. So basically, every product we offer is based on the same user account. So either it's like the store, the forum, and even device access itself. So on the cloud console, you can manage all your devices and you can assign it to different people. Just like how you can share a document in Google Drive, you can do it the same way. You can enter an email address of your friend, and this will give access of your device to that person. And then this access is constrained based on the access right you gave. So we have gave a lot of thought into the access control and device sharing, which we believe is going to be a huge part of the IoT, is how people interact with not just their own devices, but other people's devices and public devices. So all this, all this is done through our account system and access right management system.
And do you leverage any of the firewalling capabilities that are part of the typical OpenWRT distribution?
We don't necessarily use the firewall. So in our system, there's no incoming request into the device directly. So the device is actively reaching out to our server and maintains that connection once it's connected. There's no problem of people trying to hack in from the outside directly to the device. Everything has to pass through our server. And the server itself is secured through the modern web technology. Everything goes through HTTPS. The account is managed by OAuth. So we believe that the system is pretty robust, since people has already tested out all those web technologies.
And if somebody wanted to just use the Omega hardware without attaching it to the Onion cloud, is there any mechanism for them to do that, or would they just need to reflash with a different OpenWRT image?
So the Onion customized image that comes with the Omega, it's fully fledged to do whatever you want with it. You actually have to enable the cloud. Each device has its own ID that is generated on the cloud, and then the user would have to set up on the device. So until you do that setup, there's no connection to the cloud, and it's entirely optional. So you can use the device just as it's, the way it is, just a small microprocessor with these cool add-ons. But I think the real strength of the Omega comes with using the cloud. and the cloud features.
Is there anything else that you want to talk about, or any questions that we didn't ask that you think we should have?
I think we've covered a variety of topics.
Great. So for anybody who wants to follow you guys and keep up to date with what you're up to, what would be the best way for them to do that?
So we have a community forum where if it's like technical issues, then the community would be the best place to go. And if for just general updates on what we have been working on, Twitter would be a good place to see that.
So it's Onion IoT is our handle.
Okay, great. So with that, we'll move it on to the picks. I'm going to keep it short today. I'm just going to pick a movie that I watched this week called Now You See Me. Came out a few years ago, and it's actually a very well done movie. It's got some great acting in it, and the premise is that there are 4 different individual magic acts, and they all get these enigmatic tarot cards that draw them to a single location, and then they end up combining their acts into one big show where they start robbing large amounts of money from different locations and distributing that out to their audiences. And the plot line is just very interesting and well put together. The acting is great, so definitely recommend taking a look at that. It's a fun movie, and apparently they just came out with a sequel, so I look forward to seeing that when it comes out. And with that, I'll pass it to you, Chris.
Thanks, Tobias. Keeping with the theme of keeping it short and sweet, I've only got 2 picks this week. My first pick is basically a very well-engineered piece of metal. It is a portrait landscape phone or tablet stand. Essentially, I came to realize that I used to have an alarm clock on my nightstand, and I no longer do, which is fine. But because I've been using my phone, but I miss being able to sort of look up in the middle of the night and say, what time is it, without having to flounder and flail with my phone. So this thing just lets you either stand a phone up upright or lay it on its side in portrait mode and run any one of the myriad sort of, nighttime clock apps. I'll pick the app next week. But it's just a really nicely engineered little thing. It keeps the phone very stable, rubber feet on the bottom so it doesn't slide around your nightstand. And for $10, it's a pretty good value. My next pick is kind of a little more general than I would have liked, in the sense that I was going to pick my particular laptop bag, but since I've owned it for 7 years now, or 6 years or something like that, they no longer sell the particular bag, but these guys make such good bags, Tom Bin bags. And the link is in the show notes. That's BIHN is the last name. Their bags are exceptionally well designed and engineered. Each bag has like a little video to go with it to show you all the little features that the bag contains. And I've just been really singularly impressed. As I say, I've owned mine for years, and it is not showing the slightest bit of wear, despite the fact that I haul it back and forth to work every day. It's been on every flight that I've been on in recent memory, and the thing just won't quit, has not, there's not even the usual sort of like frayed edges or things like that bags suffer when they get hard daily use through the years. So you're going to pay a little more for these things, but they are totally worth it because they wear like iron. That's it for me. Lazar, what do you have for us for picks?
My pick is the movie Ex Machina. So I watched this movie a month or 2 months ago, and honestly, I still think about it on like a weekly basis. So the premise for anybody who hasn't seen it is that this enigmatic individual creates an artificial intelligence and tries to see if it'll pass the Turing test. And the movie not only explores technology, which obviously I love, but it also goes into, morality and what it means to be human. So there are so many layers to this movie that I just keep coming back to it, whether it's in, conversations at work, conversations with friends, or, just thinking about it in my spare time. So I really enjoyed it when I first watched it, and it's really stuck with me for quite a long time. I don't remember the last time a movie did that. So if you haven't seen it, I definitely recommend watching it. And
Zheng, what about you? Do you have any picks for us?
I'm afraid I couldn't contribute with this one today. I've been stuff. I haven't had a time to think about.
Sure, no problem.
You could pick the onion.
Zheng's pick is the omega.
All right. Well, I appreciate you guys taking time out of your day to talk to us today and tell us more about the work you've been doing. And I hope you enjoy the rest of your day.
Awesome. Thanks for having us.
Yeah, bye.